compounds, alright, is isomers or isomerism. Okay, before you start this part, make sure that you already completed the namings of alkene and alkene. Very, very important. You must understand how to name the alkene and alkenes. If not, if you go into this part, you're going to struggle, alright? Because not only you need to draw, you must name the structural formula. Okay, so if you don't know naming, this part will be slightly difficult for you, right? So make sure that you already completed the namings of alkene and alkene first, alright? Make sure you understand how to name. Okay, so typically for isomers, what we are referring to is the difference in the structural formula, right? So technically, if we say a molecular formula, they tell me how many atoms I have for each element, right? Structural formula, they are showing me how they are bonded. Okay, so that's why they got mentioned here, right? How the atoms are bonded. Okay, so based on the structural formula, okay, meaning for C3H7, maybe you have another way of drawing C3H7, alright, and this another way of drawing is what we call isomers, meaning they have the same molecular formula, alright, meaning they have the same molecular formula but different, okay, different structural formula, right? Okay, so what do we mean by same molecular formula but different structural formula? I'm going to show you one example using the table here. Alright, okay, I'm going to start off with this one. Alright, this is C2H6. Alright, so this one is ethane. Remember, I need to know the naming. Alright, ethane. Alright, ethane. Okay, so normally when we draw ethane, we draw it like this. C, alright, and then the H around it. Okay, make sure you always check and see whether it's correct. Okay, so 2 carbon, 6 hydrogen, so correct. Alright, but can we draw another way of C2H6? So let's say if I draw it like this. Oops. Okay, let's say if I draw it like this. C, C, now, are these two different or similar? Okay, so technically, these two are the same thing. You are basically just rotating this one downwards, alright? Meaning this whole thing, you just rotate it, okay, and then it becomes like this. Okay, so we do not call this as different structural formula. This is same. Okay, same. Alright, these two are the same structural formulas. Okay, so for ethane, C2H6, right? You are meaning you only have one way of drawing C2H6, no other way of drawing. Okay, so in that case, alright, we only have one structural formula. Okay, we only have one structural formula, therefore we do not have isomers, no isomers. Okay, you have isomers when you have different structural formulas for one compound. Okay, this one is not called different, this is same thing because you just rotate. Alright, so let me show you another example here. Okay, C3H8. Okay, this is another example. Right, so this is propane, right? 3 carbon alkene, it's called propane. So if I draw C3H8, okay, so 1, 2, 3. Okay, this is the standard one, you always draw a straight line. Okay, okay, so this is the first structure. Let me show you the second structure that I can draw. So if if I draw it like this, now is this the same or different? Okay, technically, once again, this and this are the same. Okay, they are not different. Again, what you are doing is you are only rotating. Okay, meaning if you notice this part, right? Okay, it's actually this part. Meaning I rotate this part downwards. I rotate it downwards and then it becomes an L shape. Okay, but this does not make it different. It's actually the same thing. Alright. So for propane, right, you only have one structural formula. So you don't have isomers here. Alright, no isomers. Okay, no isomers for propane. Oh my goodness. Okay. Right. So remember, this one is very, very important. Okay. Just because I rotate it downwards does not make it different. It's actually the same thing. Okay. But how do we identify different? Okay. Let me show you. This is one example. Okay. Butane. So let me draw the straight chain first. Okay. Fill up everything. H, oh my god, so many H. Heat. Alright. So this is the first structure. Okay. I'm going to draw one same and one different so that you can see the difference. Okay. Let me show you the same one. Okay. Same one is if, again, I draw it like this. Now, if you notice, this is still the same chain. There's no difference here. Alright. Okay, as you can notice, based on the main chain itself, there is actually no difference between these two structures. Okay, basically, you are just rotating the whole thing. Right, so these two, you bring it downwards, meaning you just rotate the thing downwards. So it becomes like this. Okay, now I'm going to show you a different one. This is what we mean by different. Okay, right. Okay, so this is a different structural formula. Okay, now these two things are the same. Okay, these two structures are the same. Right, no difference. But these two are different. Okay, these two things are different. Okay, because if you look at the main chain, you will notice that something is different. Here, my main chain is 4 carbons. 1, 2, 3, 4. Here is also the same thing. 1, 2, 3, 4. So technically, I'm just rotating the thing, right? There's no much difference. But however, here, my main chain is not 4 carbons anymore. Because my main chain is here. Carbon 1, 2, 3. This one is already my side chain. Okay, therefore, this one is considered as an isomer, meaning these two are isomers. This is not isomer. Okay, this one same. So remember, when it's same, meaning these two structures are not isomer. Okay, not isomers. These two are different structural formulas, right? But same chemical formula or molecular formula. So these two are isomers. Okay, alright. So that is what we mean by different isomers. What we call isomers. Okay, meaning you have different structural formula. In layman terms, a different way of drawing C4H10. Okay, this one looks different, but actually is the same. Why? Because the main chain is still the same. here I still have 3 carbons. Alright, just that I'm rotating the bond. So rotating the bonds does not mean different. It's always the same. Okay, now so let's say I draw another way of drawing this thing. Okay, if I draw it in this way, let's say for example like this, C, 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 C. Alright, now this and this is actually the same thing, right? Because this one, this part is actually here, the same thing. Okay, just that one I draw as horizontal, one I draw as a vertical. Alright, meaning I'm just rotating the whole structure. Okay, so that is what we mean by different what they call structural formulas. Okay, so in other words, very good, I can show you like this. So this one, you see, if I rotate it like this, then it becomes the same as this thing, right? So it's exactly the same, no difference. Okay, alright, that's why it doesn't matter how you draw. If you draw it like this, also the same thing. You see, if I rotate it like this, okay, this one is also the same as this thing, just that I'm rotating in different ways. Alright, okay, so it's important you understand the concept of what is different, what is same. So the idea here for me is easier for me when I look at the main chain. Right, I try and calculate and see whether the main chain is still the same. Okay, when the main chain is different, meaning it's a different structural formula, meaning these two are isomers. Okay, so C4H10. Can I have another way of drawing C4H10? I don't think so. Alright, so these are the only two structures that are correct. Okay, so this one is not isomers, so remove. Okay, this is not isomer. Alright, so these two are isomers. So here I have two structural formulas. So you must have at least two different structural formulas to be considered as isomers. Okay, so that is for alkene. Right, so what you try and do is to my way of drawing is like this. You start off with a straight chain first, 4 carbons. Next thing you do is you remove or you change it. You go one step lower, right? Meaning for 4 carbons, you change it into 3 carbons, and then the other carbon is at the side chain. Okay, and then you try and do whether you can get 2 carbons. In this case, if 2 carbons, right? You can't get a 2 carbon chain because it's the same thing, meaning it will become like this. 2 carbons, and then if I put here 2, okay, again, this thing is same as this one. Why? Because this is carbon 1, carbon 2, 3, 4. So technically, you are only rotating the first carbon go down, and then the fourth carbon you rotate it bring downwards. So this one is same. So this is not isomer. Okay, let me show you an example. Alright, okay, let's say for C5, right? What I will do is first, of course, I draw the 5 carbon chain first. Now, to draw the isomers, you try and reduce the number of carbon chains. Okay, so from 5 carbon chain, I change it into a 4 carbon chain. 1, 2, 3, 4. And then I have one more carbon, right? So I can just put it here maybe. Right, so this one will become a side chain. Okay, now let's say I try and reduce some more. This is 4 carbon chain, longest. Right, doesn't matter how. This is 1, 2, 3, 4 side chain, or 1, 2, 3, 4. This one side chain also can. It's the same thing. Or I change this into 3 carbons. So 1, 2, 3, and then another 2. Where can I put? If I put like this, it's the same thing as the first one, because you are only rotating this part downwards. Alright, so if 2 carbon chains, where can I put it? It's in the middle, meaning I put it like this. 3 carbon chains, sorry. Alright, so this will be a different structural formulas. Okay, so that is for alkene. Alright, okay, for alkene. Okay, now for alkene, it's slightly different. Okay, because you now have the double bond. Okay, when you shift the double bond, it's considered as a different structural formula because of the name. The naming is different. So let me show you. Okay, remember you need to label your numberings. Alright, oops. Okay, this is carbon 1, 2, 3, 4. Remember, double bond must always get the lowest number. Right? So this one, the name will be 1 butene. Okay, now if I change the double bond to the middle, meaning I shift this one to the middle. Okay, alright, so this one is 1, 2, 3, 4, right? So this one, the naming will become 2 butene. Okay, so technically these two things are different. So they are considered as isomers. Alright, because the name is different. Okay, this is 1 butene, this is 2 butene. If the name is different, meaning it's two different structural formulas. So they are considered as isomers. Okay, so for alkene, okay, remember alkene, first step you do is you shift the double bonds first. Alright, so you try and get different double bond position first. After that, only you try and reduce the number of carbons. So let's say this one is 4 carbon, right? Meaning because if I shift this double bond to the front, then this one will become carbon 1. So this one will be same as this one. Okay, meaning my double bond can only shift one time only for butene. Okay, so now I change it to 3 carbon instead of 4 carbon. Remember, this one is 4, right? I remove one step. Go down one step, meaning I make it into 3 carbons. Okay, and then I put the carbon here, and then I put the double bond. Okay, so again your numbering. So 1, 2, 3. Right, this one is your main chain, this one is side chain. Okay, so let me just draw out the full structure for this one. Oops, sorry. Carbon can only have 4 bonds, right? So here is already 1, 2, 3, 4. Done. So this one is 4. 1, 2, 3, 4. Okay, so this is the another structural formula. Okay, for butene, this is butene, right? So for butene, I already have 3 different structural formulas. Okay, so what is the naming for this thing? Okay, remember, this is side chain, right? So a 1 carbon side chain is called methyl, and it's at the second position. So this one is called 2 methyl. Okay, this one is 1 propane. Okay, because the double one is at the first carbon. Alright. Now in this case, if I shift the double bond to this side, it's the same thing. This one become carbon 1. Okay, because the double bond must always get the lowest number. Okay, if I shift the double bond here to this one will become carbon 1. Then this one will become side chain. Okay, so in other words, your structural formula, you need to look at it from different perspectives. Okay, you need to consider, right? But for we call alkene, okay, I would suggest first you draw the straight chain, and then you put the double bond at the first carbon first, and then you try and shift the double bond first. Okay, see how many different double bonds you can get. Alright, 1 butene, 2 butene, 3 butene, something like that. Alright, after you shift the double bond, and then can no longer shift anymore, meaning after you shift you will get back 1 butene, right? Then you reduce the number of carbons, meaning from 4 carbons straight chain, you change it into 3 carbon straight chain. And then you repeat the process. You try and shift whether you can get different double bonds. Alright, so technically for butene, alright, this one will be your isomers. Okay, for butene. Okay, alright. So for what they call different alkenes and so on, Okay, alright, you need to remember how to identify whether it's different or not. Alright, so let's say for the alkene part, okay, we move back to the alkene part. Okay, so let's say for example this one. Alright, so let's say this one, the naming. Okay, for each structural formula that you draw, you must give the name. Okay, you cannot just draw without the name. They will require you to name all the structural formulas. Okay, okay. So this one, 2, 3. Right, it doesn't matter where I start because it's in the middle. Okay, and then these two are side chains. Alright, so naming, I have 2 methyl groups at second carbon. If I have 2 methyl groups, meaning I need to write 2 numbers. 2, 2, because both at second carbon. Right, so I put 2, 2, and then since I have 2 methyl, okay, meaning it's di methyl, and then this is 3 carbon propane. Okay, so that is how you name this structural formula. Alright, so technically that is it for the isomerism. Alright, so basically your first part of your chapter 2 is already done. Okay, so you need to do a lot of exercises on this part, right, in order for you to really understand how to find the different type of isomers. Okay, so I'm going to discuss the whole naming process during our live session. Alright, our